Hi students, in this video we will continue to talk about excretion and the kidneys. We will begin with a little bit of revision, then focus on the effects of aldosterone and antidiuretic hormone on water balance, or as it is properly named, osmoregulation. Now, we already know that the kidneys are responsible for excretion, particularly of our nitrogenous waste. This waste is the result of constant anabolism and catabolism of various proteins around our body. The functionality of our kidneys can be broken down into three simple processes: tubular excretion, tubular reabsorption, as well as glomerular filtration. Let's look at a quick question on glomerular filtration as a refresher before today's lesson. Which blood vessel needs to be wider in the following diagram to generate the high pressure required for filtration? It will be the afferent blood vessel on the left-hand side. Now for today's lesson. ADH is a hormone that is released by the pituitary gland when the body detects high osmolarity or low blood volume. This is done by special cells known as osmoreceptors. ADH then acts to increase the water content and volume of our blood by causing the reabsorption of more water beyond the proximal convoluted tubule. This occurs in the distal convoluted tubule and the collecting ducts of our nephron. ADH causes the water channels known as aquaporins in these areas to open and allow the flow of more water from the filtrate back into the blood vessels surrounding them, leading to more water entering the circulatory system and a lower volume of concentrated urine being excreted. Now, aldosterone aims to perform a similar function to ADH, but uses a different mechanism. The signals for aldosterone to be released by the adrenal gland are low sodium concentration as well as low blood volume. Aldosterone increases the blood volume by increasing the reabsorption of sodium ions. When aldosterone is released, it activates a special molecular pump that moves sodium back into the blood vessels near the distal convoluted tubule. This is an active process requiring ATP. As the sodium enters the bloodstream, it creates an osmotic gradient, which the water will follow, leading to an increase in blood volume as the water follows the sodium into the blood vessels through a process we all know, osmosis. Now let's summarize today's video. ADH and aldosterone both increase blood volume. ADH does it directly by opening water channels, and aldosterone does it indirectly by creating an osmotic gradient.
Created using Powtoon.